Okay, so for part B, you guys did the first two steps. So you started with the pole and the polar axis. So you have that labeled. And then I asked you to find what your 101 pi over 2 angle was. So the quickest way to think of this is that 101 times you're going pi over 2. Okay, and one time around the circle, how many times would you go pi over 2? How many times in one rotation? 4. So if you divide this by 4, you're going to have 25 rotations in order to be back at 2 pi, okay, which would be here. And then if you go one more pi over 2, this would be your 100 rotations. Your 101 is going to be straight up to pi over 2. You can use your right angle symbol for this. Okay, so theta is 101 pi over 2. Okay, so that is steps 1 and 2. The pole, the polar axis, find your value of theta. Now in step 3, you're going to find your point. So if the point is -4, remember, instead of going out to where the angle is, you're going to go in the opposite direction. And you're just going to use a dash to show that it's in the opposite direction. And then we're going to use dash marks. So you have 1, 2, 3, 4. This is your point P. Okay, so you have -4, 101 pi over 2. Okay, so when you're labeling that, you are just putting those tick marks on there. So you have 1, 2, 3, 4. That's where your point P is. Okay, that's where you are going to label it. So what we talked about yesterday is once you do your drawing, that's your steps 1 through 3. You're going to take your given value of R. Okay, and in this case, your given value is negative. That's okay. Whatever your given value is, that is when you add or subtract 2 pi, because you are trying to find 2 other locations on the circle. So this would be 1 full rotation counterclockwise and 1 full rotation clockwise. If you want, when you're writing this out, you can just take your value of 101 pi over 2, and you can add 2 pi, and you can subtract 2 pi, and then you're just going to write each of those as a point. Okay, so you have -4, and then you're going to find that value. -4, find that second value. Okay, and once you've calculated those, I want you to go ahead and calculate the opposite. So in this case, the opposite is going to be plus or minus pi. Okay, and if you just want to write 101 pi over 2 plus or minus pi and calculate those 2 values, you can. And then you will end up with 2 points with a positive R value. Okay, so you are calculating those. So you're adding the 2 pi, you're subtracting the 2 pi. Okay, so for the first one, Victoria, what'd you get when you added the 2 pi here?
105 pi.
Great. All right, and then Jake, what'd you get for the second one?
-pi over 2.
So for this one, if you subtract the 2 pi, can you tell me what that is from the 101 pi? Because if you're subtracting the 2 pi, right, you're really just subtracting what number? Yep. So what would you get for that? Yeah, the 97. All right, and then Gabby, what'd you get for the first one for your opposite? 4 and... Yep. And then Eli, what'd you get for that last one? 499. Yep. Great. Okay, so you're just getting your common denominator, and then you are adding from there. Now C looks a little bit different, and that's because you don't have pi as your theta. That's okay. This is still a radian value. This is 1 radian. So when you are starting this, just like we always do, polar axis and your pole, when you're trying to find where 1 radian is, use what you know about the unit circle. If this is pi, this is 3.14. Half of that is 1.57. So this angle of 1 radian is going to be in quadrant 1. Okay, and then you just have to label that as theta equal to 1. Okay, your point P is at 2. You can make your units however you want. And then 1, 2, this would be your point P. And for polar coordinates, remember, we do want to practice putting those in the brackets. That is the official form of the polar coordinates. And when we go to the back, we'll be doing that as well. Okay, and then your process remains the same. So whatever value you're given, whether it's positive R or negative, in this case it's a positive R, you are going to add or subtract 2 pi. Now you have 1, so the first part of your point is going to be a positive 2. And then when you add 2 pi, we're going to keep it as an exact value. It's just 1 plus 2 pi, and then 1 minus 2 pi. Okay, so you can leave those as exact. Okay, so those are 2 of your solutions. And then yesterday we talked about how when you do the opposite value of R, you're going to be in the opposite quadrant. The opposite quadrant is always pi units away. So that's why we are adding and subtracting pi to the opposite, because we want to go to the opposite quadrant. Okay, so we start by making the R opposite, and then we can take our value, we can add pi, we can take our value and subtract pi. All right, so in our intro here, we said by the end of today, you'll be able to define the polar coordinates and understand how they're related to rectangular coordinates. So we are going to talk about that relationship on the back side. Okay, so when you are converting, there are some equations that you can use to help you convert between polar to rectangular and rectangular to polar. So when you have a polar coordinate, it's going to be an R and a theta, and it's going to be in brackets. Your rectangular coordinate is going to be the XY coordinate that you know and love from years and years of math. Okay, in order to convert, we're going to use these 2 equations from polar to rectangular. We're going to use that x is equivalent to r times the cosine of theta, and y is equal to r times the sine of theta. When we are converting from rectangular to polar, we have a different set of equations that we're going to use to find our r and our theta. Okay, so the first one is r squared equals x squared plus y squared. Okay, and a lot of people have been thinking of that as the Pythagorean theorem today. Okay, that is not going to be the Pythagorean theorem, but it's going to be more closely related to the equation of a circle, which is something that we're going to review. Okay, so the other equation is that the tangent of theta is equal to y over x. And in this case, your x can't be 0. That would lead to an undefined value. Okay, so in the first equation, they asked you to find the rectangular coordinates when you are given the set of polar coordinates. So when you are given this set of polar coordinates, remember that this is going to be your r and your theta value. Okay, for this, we're going to use the polar to rectangular. Because we're given the polar, we want to go to rectangular. So we know that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. So based on what you know about r and theta, go ahead and substitute. So you can substitute your value for r, you can substitute your value for theta, and then think about what your next step is going to be. So r is -4, theta is 5 pi over 2. Okay, what do you guys think our next step is going to be in simplifying here? What part can we simplify? Yep, so what are we going to do? What are we going to do to simplify this? Yeah, plug in the values from, your unit circle. So if you have 5 pi over 2, right, think about what that's equivalent to on the unit circle. 5 pi over 2 is the same place as what? Pi over 2. Yep. Okay, so at 5 pi over 2, you can just look at the coordinate. You have your x and y, which is your cosine and your sine. Okay, so your cosine is 0. So that is going to be your value for x. Okay, and if I take a similar approach for the second one, I'm going to be plugging in 1. And then when you write the rectangular coordinates, that's just how you're used to writing them as an xy coordinate. Okay, so it's going to be 0, -4. Okay, those are the soft brackets for the rectangular coordinates. Okay, 0, -4. All right, and then in example 3, we're going to convert the rectangular to polar, and they give you a few stipulations here. So they're telling you that your r value has to be greater than 0, and your theta has to be 0 to 2 pi. Okay, so this means our r value is going to be positive. Okay, and notice here you have a equal to and then not an equal to. So if something was at 2 pi, that's equivalent to 0. That's what you would use. Okay, so we're going to do these in 2 steps. Okay, in your first step, you're going to use the r squared equals x squared plus y squared to find r. Okay, so that's what I want you to do for part A. And then some of you can probably figure out what to do for your second step. So if you want to try that, you can. All right. So, Toby, tell me how you found R for this one.
Square negative 1.
Great.
Square root of root 2.
Good. And then, so if it tells you the R is positive, you don't have to worry about your plus or minus. Okay, you're going to use the positive value. Okay, and then for step 2, you are going to use the tangent of theta equals y over x to find theta. Okay, so I want you guys to think about what your theta is, or what it can be. Okay, so you end up with the tangent of theta is your -1. Okay, but if we think of the unit circle, how many places is the tangent -1? 2 places. Okay, in quadrant 4 and in quadrant 2. When you're doing this, you do have to pay attention to the quadrant. Okay, so what quadrant you use is going to depend on your original point. So this original point, -1, 1, if you were to graph that, okay, on an XY plane, what quadrant would that be in? -1, 1. What quadrant? Quadrant 2, right? Okay, so it's going to be the answer that's in quadrant 2. Okay, because you could have 3 pi over 4, you could have 7 pi over 4. Okay, in this case, you're going to use the one that's in quadrant 2 because it matches your point. Okay, so your theta is 3 pi over 4. Okay, your final answer, again, is going to be to write this as r theta. Okay, that's going to be your solution. Okay, so I want you to go ahead and do part B. Okay, and if you are done with part B, go ahead and start thinking about example 4. That one might be hard for you to do without a hint, but start thinking about what you could do. Okay, so for part B, Leo, what'd you get for your R value? Yep. Okay, if you did not get 4, just be careful that when you square the square root, you remember that that takes away the square root. Okay, and then in step 2, when you're doing the tangent of theta, this one was pretty nice, right? You had the same thing divided by itself. Okay, so you got 1 in quadrant 1. Okay, and Ali, what'd you get for your theta value? No, you didn't. That's not what you wrote down. Your theta, what'd you get for theta?
pi over 4.
Yeah, yep. Okay, so the tangent is 1, and then in quadrant 1, that would be at pi over 4. So 4 pi over 4. There you go. Okay. All right, now in example 4, when you are converting this equation to rectangular coordinates, you are trying to use substitution with a few of the equations that you were introduced to today, okay, with the polar to rectangular and the rectangular to polar. So you're converting this to rectangular coordinates. When they say you're converting to rectangular coordinates in this example, okay, you are writing an equation. All right, now we are going to start 8.2 today so that you can have some more exposure to what type of equations you're going to see, okay, and what these look like when you graph them. So when you take this equation, r equals 4 sine of theta, in order to use those equations we were introduced to today, your first step is going to be to multiply both sides by r. Okay, and you're going to see in just a moment why that's going to be helpful here. Okay, so if you multiply both sides by r, you're going to get r squared equals 4, and then we're just going to write 4r sine of theta. And we're going to be able to substitute in two things. Okay, we're going to be able to substitute for r squared because we know that's equal to x squared plus y squared. And can you guys see the other thing we can substitute for? That matches one of them? That, and what is the y going to be equal to? Yeah, nice. Okay, so y is equal to r times the sine of theta. Okay, so what Eli said is this side is going to become 4y. Okay, r sine of theta is being replaced by y. R squared is being replaced by x squared plus y squared. Now, the reason why you want to use this is so you can move everything to one side so we can complete the square. Okay, so move all terms to one side and complete the square. Okay, when you do move everything to one side, just organize the same variables by each other. So organize the y by the y, the x by the x. That's going to make it easier for you to complete the square. Okay, so if I subtract 4y from both sides, I'm going to have x squared plus y squared minus 4y. And then I'm going to put my blank. And then it's equal to 0 plus blank because I moved my 4y over. Okay, do we remember how to fill in those blank spaces with completing the square? Yep, b over 2 squared. Okay, so you're going to take your b value, and we're only doing this with the y because if you don't have an x, it would be 0, and you'd just be adding 0 in. Okay, so you're going to take half of b, square it, write that on both sides. Yes, with the b with the y. Okay, so we're just completing the squares with the y's here. Okay, like I said, with the x squared, you don't have any x. It would be a 0. Okay, so if I do half of b squared, half of negative 4 is? Half of negative 4 is? -2, -2 squared, 4. Okay, so see if you can write what the equation is going to be. That is going to be your final equation. I want you to think about what shape that's going to represent. Yeah, okay, so Emily, what'd you get for your final equation?
X squared plus y minus 2 squared equals 4.
Yeah, okay, so remember when you're simplifying this, what you're doing is you're factoring, right? This gets factored. Does anybody know what shape this represents? A what? Yeah, circle. Remember from your geometry days? Okay, so this is a circle. Do you guys remember how to find the center from this? And the radius? Okay, we are going to be graphing circles. So I think it's going to be helpful for us to write down the equation of a circle. Okay, so the standard equation for a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. Okay, so based on that, I want you to write down the center and the radius. All right, Jack, what are you thinking for the center of the circle? What's your HK going to be in this situation? Yep, 2's part of it, and 4 is going to be part of the, yes, part of the r squared, yep. Okay, so see how the 2's with the y? So that's going to be your k. That's going to go in the second spot, okay? And then the first one is 0. So if there's nothing added or subtracted, it's going to be a 0. And then it's the opposite of what you see. So 2 is correct. And then your radius, you just have to take this value of 4 and do what with it? Square root it. So square root of 4 is going to be 2. Okay? And these will not always be the same. It just so happened for this one. Okay, so you are going to be graphing circles. We can do that in polar coordinates. So we're going to see a little bit of that today. And again, that's because when you're converting to the rectangular equations, it's going to be really helpful if you see what those look like. Okay, so we're gonna look at just the first part of 8.2.